Imagine waking up one day, and the compass on your phone just spins wildly, pointing nowhere. North is no longer north. It sounds like the opening scene of a disaster movie, right? But what if I told you this isn't science fiction? This is a very real phenomenon baked into our planet's operating system, known as a magnetic pole reversal. And the signs are pointing to one happening sooner than we might think. What would this mean for us, for our technology, and for life itself? Let's dive deep into the heart of our planet to find out. Before we get into the chaos of a flip, let's appreciate the invisible hero that protects us every single second of every day: the Earth's magnetic field. Picture our planet as a giant bar magnet. Deep within the Earth's core, an ocean of molten iron is churning and sloshing around. This movement of liquid metal generates powerful electrical currents, which in turn create a massive magnetic field that extends far out into space. This field is called the magnetosphere, and it's our planetary shield. Every day, the sun bombards us with a constant stream of charged particles, known as the solar wind. Without the magnetosphere, this radiation would strip away our atmosphere, boil our oceans, and make life on the surface impossible. Our magnetic shield deflects the vast majority of this harmful energy, funneling it safely around the planet. You can actually see this shield in action. The beautiful, shimmering lights of the auroras, the northern and southern lights, are the visible result of solar particles interacting with our atmosphere near the poles, where the magnetic field is strongest. It's a stunning reminder of the cosmic battle being fought for us silently, overhead. But this protective shield isn't static. It's a dynamic, ever-changing force. And for centuries, scientists have known it's weakening. The magnetic North Pole, the spot our compasses point to, isn't fixed. It's been wandering away from its historical position in the Canadian Arctic, moving towards Siberia at an accelerating pace. In recent decades, its speed has increased from about 15 kilometers per year to a staggering 55 kilometers per year. This rapid drift is one of the biggest clues that something significant is happening deep within the Earth's core. This isn't the first time our planet has done this. By studying ancient rocks, particularly cooled lava flows, geologists have created a timeline of Earth's magnetic history. When volcanic rock cools, tiny magnetic minerals within it align with the direction of the magnetic field at that time, essentially locking in a snapshot of the past. It's like a planetary tape recorder. And what this record shows is astonishing. The Earth's magnetic poles have flipped hundreds of times over its history. North has become south, and south has become north. These reversals don't happen on a regular schedule. Sometimes millions of years can pass between flips, other times just a few 100,000. The last full reversal happened about 780,000 years ago. So, based on the average rate, you could say we're a bit overdue. This isn't a sudden overnight switch. The process is thought to take thousands of years, during which the main magnetic field weakens significantly, and multiple smaller, weaker north and south poles can pop up all over the globe. Your compass wouldn't just point to a new north, it might point east, west, or just spin in circles depending on where you are. So, what would it be like to live through a magnetic pole reversal? The biggest concern is the weakening of our magnetic shield. During the transition, the main field's strength could drop to as low as 10% of its current power. With our primary defense down, more solar and cosmic radiation would reach the Earth's surface. This could increase the risk of certain health issues for humans and animals. It could also damage our DNA, though it's unlikely to be a mass extinction-level event, as life has survived countless reversals before. Our atmosphere still provides a substantial amount of protection. However, the greatest and most immediate threat would be to our modern, technology-dependent civilization. Our entire global infrastructure is built on a foundation of stable electromagnetism. Think about it. Power grids, satellites, GPS, and all forms of communication, from the internet in our homes to the navigation systems in airplanes and ships. A weakened magnetic field would make this technology extremely vulnerable to solar storms. A solar storm is a massive eruption of energy and particles from the sun. Today, our strong magnetic field deflects most of these. But during a reversal, a powerful solar storm could be catastrophic. It could induce massive electrical currents in our power grids, overloading transformers and causing widespread, long-lasting blackouts. It could fry the delicate electronics of the thousands of satellites we rely on for everything from weather forecasting to financial transactions. GPS would become unreliable, air travel would be severely disrupted, and the internet could go down. We're talking about a potential technological apocalypse, sending us back decades in an instant. The effects on the natural world would be profound as well. Many animals, including birds, sea turtles, and whales, have an internal magnetic sense, called magnetoreception, which they use for navigation during long migrations. With a chaotic and weak magnetic field, these creatures could become lost. We might see birds flying in the wrong direction, and sea turtles unable to find their nesting beaches. While many species would likely adapt over generations, the short-term disruption could be significant for certain populations. So, what are we doing about it? Scientists around the world are monitoring the magnetic field with unprecedented detail, using satellites and ground-based observatories. They're feeding this data into complex computer models to better understand the processes happening in the Earth's core and to try and predict what might happen next. Engineers are also working on ways to harden our critical infrastructure. This includes developing more resilient power grids and satellites that can better withstand intense radiation events. It's a race against time, trying to prepare our fragile technological shell for a planetary process that is unstoppable. But there's no need to panic. Remember, this is a slow, natural cycle. The transition itself would likely take longer than a human lifetime, giving us time to adapt. It's not an asteroid impact. It's a slow-motion, global challenge. It's a reminder that we live on a dynamic and powerful planet, and we are just along for the ride. The Earth's core is whispering, telling us that change is coming. The question is, are we listening? Understanding these grand cosmic and geological cycles gives us a powerful sense of perspective. It forces us to think on a longer timescale and to appreciate the intricate systems that make our life here possible. So the next time you see the northern lights or simply use your phone's GPS, take a moment to thank that invisible magnetic shield. It's our planet's silent guardian, and its story is one of the most incredible tales our world has to tell. Thank you so much for joining me on this deep dive into our planet's magnetic heart. If you found this fascinating, make sure to hit that like button and subscribe for more explorations into the wonders of our universe. Let me know in the comments what you think. Are we prepared for a flip? Until next time, stay curious.